my name is Conrad, and this is my definition speech. Usher, Angelina Jolie, Gwen Stefani, Neo, Albert Wesker, and Arnold. What do they all have in common? They have killer sunglasses. Now, what exactly makes killer sunglasses? Well, they're usually very expensive, name brand. But if you get the really nice ones, they're also polarized. And I was talking to one of my friends the other day, and when I said polarized, he said, ooh, pretty colors. So I decided to define polarizers and their effect on light. Now, first we have to start off, what exactly is light? Well, light is around us. It makes us see. We really can't function without light. What it definitionally, what it is electromagnetic radiation, broken down into photons, which the best way to think about it is just this little bundle of light. It shoots around the room. It has two waves, the electro and the magnetic. There are these two waves at right angles to each other. As you can see in this picture right here that I got off an Astronomy Notes website, they move along, oscillating, both hitting crests at the same time and both hitting troughs at the same time, going in right angles to each other. Right angles. Now, what a polarizer does is they take this, and every time you see light, their electric vectors are all going in different directions. So you can imagine it as basically just a big circle shooting at your head every moment of the day. Now, with that circle, they're going in all different directions, all different wavelengths. Polarizers do not affect the wavelength at all. The wavelength stays the same no matter what, with the exception of some few extraneous cases that I'll go into in a moment. But the polarizer, the light comes through, hits the polarizer in the sunglasses. It will be the lenses of the sunglasses. And it will absorb all light that is not vibrating with its electric vector in the same direction as the polarizer. For example, if you see a polarizer, which is just usually just a little square, it'll have an arrow on it denoting which is the polarizer direction. Anything that is not within that direction gets absorbed, and that's why a polarizer will look dark, because it's absorbing most of the light, about half the light. Shortcliffe, defines it as an optical device when supplied with only unpolarized light, transmits polarized light. Just as an example, this up here denotes a direction of the polarizer. You can have any really direction you want, including perpendicular to it, along it, and in any other direction. I only did these four just to save time, but it's really anything that is green could be a light with its electric vector going in that direction. However, when you add the polarizer, it resolves that. You see, we have the white line that is just as it was, but these two lines are diminished in intensity. The light is not near as bright. The red line, which we saw, was perpendicular to the direction of the polarizer, is actually completely absorbed. You don't see it at all. Now, Ballard described polarization as not really polarizing it, as in saying one is north, one is south, but really just cutting light in half and simplifying it, saying, okay, yes, it is in this. It is going to vibrate in this direction. It will always vibrate in this direction, because otherwise we really haven't polarized anything. Now, just as a little fun example, what happens in the instance of cross polars is when you have a polar direction, for example, going this way, and then another one on top going that way. I have a sample of beer right here, just because I thought for colors that would be a nifty little example to use. And you see all the pretty colors that my friend was talking about before. The dark portions are the thickest part. It goes by thickness. Anything The thickest parts will actually be lighter colors. So this part is thicker than these up here. And this is caused by the resolution from the initial polarizer in this direction to the secondary polarizer, usually called the analyzer, across the top. So this is just an example of what a polarizer is and how it works.